am going to give the problem number 2. Problem number 2. The previous example is single acting cylinder. Now this example is double acting cylinder. The same type of problem, but here we are using double acting cylinder. See here, this problem is a double acting cylinder. A double acting cylinder is getting forward stroke. Is getting forward stroke.
When 3 by 2.
When 3 by 2. 3 by 2 way normally closed. Switch is pressed. Switch is pressed.
When 3 by 2.
The cylinder will get reverse stroke when 3 by 2 valve is released. The forward stroke is controlled by a flow control. See here, the problem number 2. Problem number 1 is single acting cylinder and problem number 2 is double acting cylinder. The double acting cylinder is getting forward stroke when 3 by 2 way normally closed switch is pressed. The cylinder will get reverse stroke when 3 by 2 valve is released. The forward stroke is controlled by a flow control valve. So the same type of question here, double acting cylinder. Before that you have to think, so what are the components required to solve this problem? The first one is double acting cylinder because it is given. Double acting cylinder.
5 by 2.
Then see the double acting cylinder is getting forward stroke when 3 by 2 way normally closed switch is pressed. So definitely one 3 by 2 way valve is required. The second one is 3 by 2 way normally closed switch. See, when 3 by 2 way valve is released, then automatically it should come back. The forward stroke is controlled by a FCV, the flow control valve. 3 is flow control valve. When I am going to do a rough work, see that 3 by 2 way valve, 3 by 2 way switch. So when I am going to press, it should go to FCV and it should go to double acting cylinder. See, this information only available in question. So when I am going to draw using the symbols, if I am going to put 3 by 2 way switch, flow control valve and double acting cylinder, these 3 components, it is wrong. Why? See, the cylinder will get reverse stroke when 3 by 2 valve is released. In the double acting cylinder, there is no spring. It will not return automatically. It will not return automatically. So that's why you need another one valve here, 5 by 2 directional control valve. So you have to use 5 by 2 directional control valve because the double acting cylinder mechanism is, this is the double acting cylinder, this is the double acting cylinder. The forward stroke, when you are going to apply, the forward stroke will happen at that time. The used air which is available in the right side should release. If you want to get back, you have to apply some amount of air in the right side part of the double acting cylinder. Then this air should release. So for both the sides you have to apply the air. The 3 by 2 way switch will not allow to apply in both the sides of the cylinder. The 3 by 2 way switch is not enough to apply the both. See that this is only one 3 by 2 way switch, means when you are pressing that the air will flow. When you release that, the air will not flow. This is the 3/2 way switch. Okay, function of the 3/2 way switch. So then how can we achieve? When you are going to switch on that, see there you are allowing, then double acting cylinder will extend, so it will not come back. If you are releasing, it will not come back. So you need additional component which is called as 5/2 directional control valve. So 5/2 directional control valve, why we are using? Because of getting reverse stroke. Because of to get reverse stroke in the double acting cylinder. Whenever you are using the double acting cylinder, 5/2 directional control valve is must. Understand? Understand? Again you tell. Whenever we are using double acting cylinder, 5/2 directional control valve is must. So before that you have to, so it should come in your mind automatically by when you are seeing the double acting cylinder in the problem, you have to add what? 5/2 directional control. So here you are going to add, before FCV, you are going to add another one block, 5/2 DCV. Then it is going to the flow control valve, and then after that it is going to the double acting cylinder. Now only the problem is perfect. So I am going to fill with symbols. The first one is 3/2 base switch.
After that, the
3/2 base switch. See, the symbol for the 3/2 base switch is, this is 2 position. There is a 3 port. This is 2. This is 3. This is the exhaust port, and this is the inlet port, and this one is the normally open position, 1 to 2. There is a push button, and this one is the spring release. So you have to connect always. See that when I am going to put one 5/2 valve, 5/2 way valve, 5/2 way valve, what will come? There is a 4 and 2, 1 to 2. There will be a inlet, and then 4 to 5 will be the exhaust, and another one position, the 3 will be the dummy. 4 to 5. This 3 is also for exhaust. 5 is exhaust, and 1 is for source. So through 1 we are giving the source. So when you are going to give, the 1 to 4 will come upward direction here. 1 to 4 will come upward direction in the normally open condition. Then 2 to 3 will come for the exhaust. 2 to 3 will be the exhaust, and here will be the inlet, and then 5 will come as a dummy. So this is the symbol for this 5/2 way valve. 4, 2, here 3. This is the symbol. Okay. See, when I am going to connect, I have to connect only this normally source, not this. You should not connect. This is wrong. You should not connect. See the connection. Somebody asked, no, connection. Somebody asked here. Connection. How to connect this? So you should not connect this. This is wrong. This is wrong. You have to connect always the right side part. This is the right side part. What I mean? This is 2 position. 2 position. Normally close to position. Normal position only. Normal position symbol only. You have to connect. Okay. So you have to connect. So this when you are going to give. See the pushing operation will be done by air. Okay. When you are allowing the air, here you are pushing. The manual pushing. Here the compressed air is pushing. The normally closed position will be changed to normally open position. Okay. So here also you have to connect the normal position to the cylinder. See the normal position to the cylinder. Why? See that this is the normal position is the extreme reverse stroke. How will happen extreme reverse stroke? How will happen extreme reverse stroke? When you are applying the air in the right side part of the double acting cylinder. Right side part of the double acting cylinder. So which symbol is giving air, inflow air? 1 to 2. See there 1 to 2 arrow mark is giving, going upward. That going upward air you have to connect in the right side part of the cylinder. Then only you will get the normal stroke. So the left side part what will happen? This will come to exhaust. So when you are going to apply the air here, this air will come exhaust. So that's why this is the exhaust port connected here. So the exhaust port, you have to connect with the exhaust port, that is the arrow mark down. Arrow mark, see the arrow is down, so that is for exhaust. Arrow mark up is inflow. Correct? Input. The input for the normal position, where I have to give the input? Only the right side part of the cylinder. So right side port I have to give, so that's why I have connected this air inflow to the right side part, and the air outflow I have connected to exhaust. Okay, so you need not to bother about the left side part of 3x2 valve, 3x2 valve or 5x2 valve, because automatically it is understood. Yes. Yeah, I'm coming. See there, now I have connected. See, there is the forward stroke is controlled by a FCV. The forward stroke is controlled by a FCV. Still, I haven't included this flow control valve. I have to include in the forward stroke. Which one will achieve the forward stroke? When I am going to press, this line only will come. 1 to 4 only will come in flow. Correct? Through 1 to 4, if the air is going, then only I will get forward stroke. The forward stroke line is this line. Correct? This is the forward stroke line. If I am including here, only reverse stroke will come in a controlled way. But the problem is saying the forward stroke is controlled by a FCV. So flow control valve I have to include here. This is the symbol for flow control valve. So I have to include here the flow control valve. This is the flow control valve FCV. See that when I am going to press, the air will go upward. It will change the normally closed position to normally open position. The air will flow from here to here. The compressed air will push. Instead of manual pushing, compressed air will push. The mode will be changed from normally closed to normally open. Then air will flow through the flow control valve, and then it will go here. Then it will get forward direction. Then what will happen? The reverse stroke, the cylinder will get reverse stroke when 3x2 valve is released. If I am releasing this, air will be stopped. The air will not go here. So what will happen? This should come to normally closed. How it will come? It should come automatically.
Yeah.
It should come automatically. That's why you have to include one spring. This is called, the spring return is important. So for this type of application, spring return is important. When you are releasing this push button, automatically it will come to normally closed position using spring return. Okay? So see here, now whether it is satisfying or not, you have to check. When I am going to say the double acting cylinder is getting forward stroke when 3x2 way, normally closed switch is pressed. See, I am going to press this. I am going to press this normally closed. Then it will come to normally closed position to normally open position. Then it will go here. The compressed air will push the spool. Then it will change from this mode to this mode. Then automatically air will flow to cylinder through the flow control valve. It will get forward direction. If I am releasing this, the air will be stopped here. Air will be stopped here. Air will not flow. If air is not going, the spool will come to normal position. Because of spring return is available, then again it will come to normally closed position. Normally closed position means air will flow to right side part of the cylinder, then it will get back. The cylinder will achieve extreme reverse stroke when I am not pressing this 3x2 wave valve. Okay? Understood? Yes.
This is the 5x2 valve, right?
Yes,
we
this is 5x2
valve. We
yes.
should have two connected 3x2 valve. Because
This
there you are putting the, what they call it, spring.
Yes.
Other than putting spring, why are you not putting 3x2 valve?
I'm not getting.
5x2 is with the brake.
Please, once again. Please, once again.
I'm telling you that as soon as you have 5x2 valve,
Okay, 5x2 valve I'm having. Yes.
it's most of the time you should put two 3x2 valve connected together.
This one, this is connected together.
Yeah. This is one and the other one.
Other one sometimes, okay.
Yeah.
Okay.
How could I know when I have to put it and when I don't?
Oh, this one, why spring return and say that if I am giving, if it is added, the cylinder will get reverse stroke when another 3x2 wave switch is pressed. You assume. Here, only one 3x2 wave switch is there. See that based on the question you can understand. A double acting cylinder is getting forward stroke when 3x2 wave switch is pressed. When I am pressing that, air is going, here it is pressing, So it is changing, then it is getting forward stroke. The reverse stroke should happen if I release this. See, if I am changing this valve, the cylinder will get reverse stroke when another 3/2 valve is pushed. Here released. Instead of that, if I add like this, the cylinder will get reverse stroke when another 3/2 valve is pushed. At that time, you need not to have this spring. You are going to have another one 3/2 way switch. Okay? Another 3/2 way switch. See, this is the symbol for this. Then when you are going to connect here, this time only another 3/2 space switches. Okay? See there, when I am pushing this, it's going here, you will get forward stroke. When I am pushing this, then the air will go, this will change the mode to normally open to normally close, then air will flow here, it will get back. When I am pushing this, it will get forward direction. When I am pushing this, it will get reverse direction. So there are two switches. So the initial one it said, there is only one push button. If I am releasing that, it should come back. So that's why I have included the spring return. It should come automatically. Only thing, see like your calling bell. I have to push. If I release that, it should come to normal position. The earlier one was like that. This one is two-way switch. Understand two-way switch? You have to switch on and you have to switch off. Like our light control switch. Like light control switch, you know, you have to switch on that and you have to switch off. But when you are going to use the calling bell, you know calling bell?
Ring.
What? Doorbell. What is in Arabic?
Yes.
Garas? Garas.
Yeah.
Okay. So that bell, if I push, it will ring. If I release that, what should happen?
It will stop.
It should stop. Or otherwise some kid will come and then if they are pressing, then keep on ringing, so that will give trouble. Okay, so the same way here also the extension should not happen, should not happen. Okay, if I release that again, immediately it should come back. So that's why I have kept the spring return one. Okay, so we'll go for the next circuit. Okay,
Sir,
any doubt?